A store owner, oh, I should introduce this. This is the calculator section of the PARCC 7th grade practice test, and this will be problems 15 through 17. Sorry, 10 through 17. 10 through 17. All right. With that said, a store owner paid $15 for a book. She marked the book up by 40% to determine the sales price. Now, so this means that 40% of whatever people pay, she gets to keep. Campbell, can you answer that and tell Mom, and tell her that I cannot talk right now? All right, so what is the selling price in dollars? And this is a calculator question. So the first thing I'm going to do is, oh, look, our schedule. Okay, so I'm going to pull up my calculator really quickly, and it's just easier to do this on the calculator. Oh my gosh, right there, come on. Okay, so since that's not coming up. All right, so $15, and if I mark it up 15% or 40%, that means that 100% is the value that I bought the book at. That's the $15 plus another 40%, and so in total we're going to sell a book for 140%, which is equal to 1.4. So I'm going to multiply 15 by 1, multiply by 1.4, I get $21. So I will go ahead and type in $21 into my answer blank. And so I'll do that now. So I guess I'm going to have to do this sitting down, which is kind of a pain. But here we go. Anytime now. It's been a bad day with this board. And it's not working at all. Brilliant. Okay. So in that case, I'm just writing 21. All right. So then, we'll get rid of that. So the customer buys a different book that has a sales price of $38, but the book has been discounted by 25%, and then we have 6% sales tax. So first I need to figure out what the discount is, because you only pay sales tax on what you spend, not what the original price is. So if my original price was $38 and it was discounted by 25%, well, that means 25% of the cost has now disappeared. So what percent of the cost remains? 75%. So an easier way to do this is just to multiply my original sales price by the percent of the book that I will have to pay for, the 75%. And so the actual price of the book is $28.05. But wait, I have my sales tax. And just like with the problem part A, I have 100% of the cost of the book, plus I'm going to add to it 6%. So I have a total of 106% of the sales price that I must pay, which is equal to 1.06. So I'm going to multiply the 28.5 times 1.06, and the end cost of the book, the actual amount of money I must pay to the store, is $30.21. The store owner gets to keep $28.50, and she has to give the remaining to the local city or state. All right, number 11, maybe. But of course, it won't go anywhere. Let's see if this will help. Okay, so there's my 21. Here's my $30, and Oh, how many cents? I think it was 21 cents. I may be off on that, I don't remember. Yep, 21 cents. Okay. So, going on to the next problem. All right. Let's see if we can get it to work this time. So, this time, it's still not going to work. Oh, it's been a bad day. All right, well, so in this problem, we have a clay figure. And this clay figure, I have two of them. I have a cube, and the cube looks like this. And you'll remember that the distinguishing characteristic of a cube is that all the side lengths are the same. Therefore, this face right here, is going to be a square, as is all of the other faces. And then I also have my rectangular base, or square base pyramid. And what I'm going to be able to do is I'm going to be able to cut both of the figures using a vertical or a horizontal line. But that's it. And I'm being asked whether I can produce a triangle, a square, or a rectangle that is not a square from these cuts based on my cut line. So let's look at the cube first. Is there any way that I can cut this figure to make a triangle? Well, if I cut it right here in this vertical line, I get a square. So obviously that's going to be so no triangle so far. Let's see if I cut it this way. Oh, that's another square. Actually, this, when I say this, I mean this face is going to be a square because it is parallel to the face on the front and the face on the back. This cut line is also a square because it runs parallel and is the exact same size as the top and the bottom. So I'm having troubles making a triangle. There's one other cut that I can try here. I can cut, let's cut right here. Well, that's not a triangle, but it is a rectangle that is not a square. So I can do this one as well. Looking at my my pyramid, clearly if I make a vertical cut right at the top of, it goes right through the top of my pyramid, I'm going to make a triangle. Now, incidentally, if I make a cut right here that's vertical, what shape will I make? Well, that, although it doesn't look too great, that is actually a trapezoid. But that's not one of the options, so I'm not going to worry too much about it. What happens if I cut it like this? I do have a square. Okay, so I can make a square and a triangle. And there's one other thing that I can try that I haven't tried yet. Let's cut it with a vertical line sort of lopping out from one of the corners. And so that would end up giving me a shape like this. And that is another triangle. So I cannot make a non-rectangle square in this one. All right, moving on to the next problem. I'm going to have to keep going back and forth to this, which is a pain, but there's not much else I can do. All right, moving on to the next problem. All right, the directions on a bottle of vinegar say, mix 1 cup of vinegar and 1 gallon of water to make a cleaning solution. So that makes a ratio of vinegar to water of 1 to 16. And why? Because there are 16 cups in 1 gallon. All right, so let's see if I can make anything happen here. Nope. All right, so how many cups of water should be mixed with 1/4 cup of vinegar to make a cleaning solution? So this is essentially a scale factor problem. If I have 1 to 16, which is my stated ratio, and it's highlighted right here, and now I have 1/4 to something. The question is, what did I multiply, or in this case divide, 1 by to get 1/4? So to go from here to here, I multiplied by 1/4. Well, what I do to one term, I have to do to the other. So 16 times 1/4 is a grand total of, that's right, 4. How many fluid ounces of the vinegar should be mixed with 80 fluid ounces of water to make a cleaning solution? So now we have 80 fluid ounces. So the question is, what did I multiply 16 by to get 80? Because I'm looking for this number right here. Well, as luck would have it, and I can pull up my calculator because this is the calculator section after all. I can do 80 divided by 16. I get 5. There we have it. 5. Brilliant. I need to scroll down now. So then for C is now asking, what is the total number of quarts? So now we want the total number. Well, if I have 1 quart of vinegar, and I have a 1 to 16 ratio, how many quarts of water do I need? Well, obviously I need 16. So if I have 1 quart of vinegar mixed with 16 quarts of water, I have a total of 17 quarts of liquid, which is 17 quarts of cleaner. A spray bottle holds 1 cup of cleaning solution. Well, if I have 1 cup of cleaning solution, and if I look back to this answer, I have 1 cup of vinegar and 17 cups of cleaning solution. What fraction of this cleaning solution is vinegar? Well, clearly it's 1/17 because it's the part over the whole. And so if I have 1 cup of cleaning solution, then I have 1/17 cups of vinegar. Good luck coming up with 1/17 of a cup of vinegar, but that's what you got. All right, moving on to the next problem. All right, number 13. Josephine owns a diner that is open every day for breakfast, lunch, and dinner. She regularly has a menu, she has daily options. She surveys 15 lunch customers, and 28% of them order from the specials menu. All right, which statement makes the most sense? Well, the sample size is the percentage of the customers who ordered it. No, the sample is the 50 total customers, so that's not right. Pow! The sample might not represent the population because it only includes lunch. I don't mind that answer so much because I was a server for a little bit, and lunch customers and dinner customers are clearly don't do the same things. But that's not the best option, but I'm going to leave this one open just in case it is the only option. The sample shows that exactly 28% of Josephine customers. Well, no, it just means this sample shows that many. Finally, no generalizations can be made for the sample because it's too small. That is clearly the right answer here. 50 customers out of the life of a reasonably busy restaurant is not really that many. You need far more. So clearly, D has to be the right answer. All right. Today, Joelle walked 20 minutes at a rate of 3 miles per hour, and she ran 15 minutes at a rate of 6 miles per hour. Well, I know. I know that 20 minutes is 1/3 of an hour. So for 1/3 of an hour, if I go 3 miles per hour, that means I've gone a total of 1 mile. And I know that 15 minutes is 1/4 of an hour. And if I do 1/4 of an hour at 6 miles per hour, I will get 6/4, which is better known as 1.5. So how far have I gone in total? Well, 1 mile plus 1.5 miles. That's sloppiness is 2.5 miles. Now, Joelle wants to travel a total of 4 miles, a noble goal, by walking and running. She runs 20 minutes, and again that's 1/3 of an hour, at 6 miles per hour. And so that gets her 22 miles. That means she needs to go 2 miles.
What is up with your hair today?
I need to go 2 miles, and I need a certain fraction here. And that's going to equal, sorry.
What?
Sorry.
The stupidest thing I've ever heard.
Oh, Yema's belittling my child here, as he probably should be. So 2 miles, because that's how much further I need to go, is going to be equal to the time that I do it times my speed, and my speed is 3 miles per hour.
He's talking to himself.
So 3 times something is 2. Well, what is that? Well, what's the opposite of multiplying by 3? Dividing by 3. So I'm going to divide both sides by 3. I'm going to change colors here. So if I divide by 3, divide by 3, I'll end up with 2/3 is equal to my fraction. Therefore, I need to go 2/3 of an hour, but I can't write 2/3 of an hour here. What is 2/3 of an hour? Well, if 1/3 is 20 minutes, then I must walk 40 minutes in order to complete my goal. And Mr. Weiss would be proud. All right. Proportional relationships. Proportional relationships basically are linear relationships that start at the origin. So point P is at 3, 2. So that's over 3 up to, and I click, pow! I get a blue dot for point P. Now I need point Q. And I know that point Q is going to be at something, 6. Something, 6. So here's the question. What did I do with 2 to get 6? Anya, what did I multiply 2 by to get 6? 3. So what do I have to multiply? So I have to multiply 3 by 3, and 3 times 3 is? 9. So therefore my x value is 9, so I have 9, 6. Kapow! There we go. And we are done. All right, 2 more to go. And now we're going to need writing implements. All right, so first let's find what is the area in square inches of the triangular shape region. So that is only this piece right here. And I know to find the area of a triangle. The area of a triangle is going to be base times height divided by 2. So in this case, my base is 2. My height is 4. And I'm going to divide it by 2. And I get 2 divided by 2 is 1. So I just get 4. 4. All right. finally, what is the area in square units of the non-shaded region? Well, there are two ways I could do this. I could find the area of this, 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 and this. Or I could find the area of the whole and subtract out the shaded regions. I think I want to do that. So the area of the whole thing is going to be 5 times 8, which is 40. So the area of the whole is 40. But I don't want the area of the whole. I want the area of just the non-shaded region. And we've already discovered that the area of this is 4. So we need to find the area of this shape. Well, the length from here to here, I'm going to break this shape into two pieces. I'm going to find the area of this shape here, and then the area of the bottom shape, and combine them. So if this whole... Oh, wait a second, Anya. We made a mistake. Do you know what the mistake is, Anya? 5 times 8 is 40. But this rectangle here is not the whole rectangle, is it?
No.
I lopped off the top. Woe is me. So, the whole rectangle is going to be 8 by 6. What is 8 times 6?
48.
Oh, it is 48. So the whole area is 48. And I'm going to subtract a total of 4 and then these two regions here. So if this whole segment is 6, and we have 5 of it accounted for here, what's 6 minus 5? 1. So this must be 1. 1 times, well, what's this distance? It is 8 minus 2, which is 6. So that means this area is 6. And this area here is going to also be 1, because this whole part here is 2. Here's 1 of it, so there's 1. And this segment here is 6 minus 3, which is 3. So 1 times 3 is 3. So I add these together, 10 and 13, so we have 48 minus 13, and 48 minus 13 is 35. So 35 is the answer down there. All right, last problem. I'm so excited to be done with this, as I am sure now you're probably jonesing for this to last forever. Like, no, Mr. Frank, you make more videos. But I'm going to be done here on this problem. All right, so Regan, whatever, will use a random number generator 1,200 times. Each result will be a digit from 1 to 6, which is the best statement that shows how many times 5 will appear. Well, the first thing I'm going to do is I'm going to say 1,200 divided by 6, because there are 6 options, is equal to 200. So the most likely number of times the 5 will appear is going to be 200 times. However, are we assured it's going to be exactly 200 times? No. It could be any number between 0 and 1,200, although those two are really not likely. Will it appear exactly 200 times? No. That's the most likely outcome. It will appear close to 200 times, but not exactly 200 times. That is clearly what the probability tells us. These two are wrong, and they are assuming that you had the folly of dividing 1,200 by 5, but you're too smart for that, so we don't need to worry. All right, so those are the problems on the back half of the calculator portion. I hope you found that helpful.